Okay, we are going to finish up our notes on section 5.3. On this one, the first thing I notice, well, one, it says between 0 and 2 pi, so I want to make sure I list every possible answer that falls in that range. But this also looks very similar to a quadratic. And if I want, I could write this as 2x squared minus x minus 1 equals 0, and just know that my x's actually represent sine x. If you want to do it that way and factor it there, that's fine. If you want to leave them as sine x, that's fine. Whatever works best for you, just make sure you do end up back with the sine x in your final answer. Again, there are numerous ways to factor this. One way would be to do 2 times negative 1, which is negative 2. So I'm looking for numbers that multiply to negative 2 and add to negative 1, which would be negative 2 and a positive 1. So instead of negative x, I will rewrite this with a negative 2x and a positive 1x, and then minus 1 equals 0. So I just kind of split that middle term. If I group the first two together, I can factor out a 2x, and I'm left with x minus 1. The second pair, I can factor out a 1, and I'm left with x minus 1. So this is factored into 2x plus 1, and x minus 1 equals 0. So over here, this is factored into 2 sine x plus 1, and sine x minus 1 equals 0. If I set each of those equal to 0, so 2 sine x plus 1 equals 0, solve this just like we did in class. So this would be equal to negative 1, so sine x would be equal to negative 1/2, and then I can say, well, that happens in the bottom two quadrants in 3 and 4, because sine would be negative down there. At those two dots, the 7 pi over 6 and 11 pi over 6. So x equals 7 pi over 6 and 11 pi over 6. I also need to set my sine x minus 1 equal to 0. So I'm going to get sine x equals 1, which would happen at pi over 2. So my three answers are pi over 2, 7 pi over 6, and 11 pi over 6. On 6, again, it kind of looks like a quadratic, so I am looking to factor it, but I have two different trig functions there. I have to have the same trig function, so I need to rewrite either my sine squared is hopefully with like a cosine squared, or I need to write my cosine. I can use, since this is squared, I can use Pythagorean identities, and instead of 2 times sine squared, I could use 2 times 1 minus cosine squared x, because sine squared is the same thing as 1 minus cosine squared. From there, I can distribute my 2. Combine like terms, so I get negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. When I'm looking to factor, I don't want a leading coefficient that's negative, so I can either think of adding everything over to the other side or multiply the entire equation by negative 1. But either way, all of my signs are going to change, because you do not want a negative out front when you are factoring. You just want it all to be positive. It's going to make it a whole lot easier. Alright, so once I get this set up as a quadratic, again, if you need to, come over to the side, factor this equation, and if you need the time to do that, do go ahead and pause that. Once you have factored that, over here, if you're doing it to this side, I should get 2x minus 1 and x minus 1, which will turn into 2 cosine x minus 1 times cosine x minus 1 equals 0. Then I'll set each of these equal to 0. When I solve this one, I'm going to add my 1 over, so 2 cosine x equals 1, and then divide by 2, so cosine x equals a half, which if I think about my unit circle, cosine would be my x, positive, so that'd be in quadrant 1 and quadrant 4. Should be at pi over 3 and 5 pi over 3, but because this said find all solutions, I'm going to have pi over 3 plus 2 n pi and 5 pi over 3 plus 2 n pi. Over here, cosine x equals 1, which happens at 0, so I'm going to have 0 plus 2 n pi, which really is just 2 n pi. You don't need the 0. I would not take off with the 0, but the 0 is not needed and would not be given on a multiple choice test. Okay, 7, find all solutions in the interval of 0 to 2 pi. So I am just looking for the ones that are between 0 and 2 pi. Again here, I have two different trig functions. None of them are squared. It's the only way that I can switch between sine and cosine is if one of them is squared. So let's square both sides. When I do cosine x plus 1 times cosine x plus 1, I get cosine squared x plus 2 cosine x plus 1. And then on the right side, I'm just going to have sine squared x. Okay, now that these are squared, I can rewrite one of them. Because I already have just a regular cosine, I want to try to get everything to cosine, since I can rewrite this sine squared is 1 minus cosine squared x. Nothing over here changed in that process. Okay, get everything on the same side. So that's 2 cosine squared x plus 2 cosine x equals 0. And I notice I got rid of my third term, so I'm not necessarily looking to factor in your normal sense like we've been doing the last couple of problems. I am just kind of looking to factor out, and they both have a 2 cosine x. So I'd be left with cosine x plus 1, and then equals 0. Now that I have my two factors, or two things multiplied to equal 0, I'm going to set each of them equal to 0. So here, when I divide by 2, I get cosine x equals 0, which cosine equals 0 at pi over 2 and 3 pi over 2. And then for this one, I'd have cosine x equals -1, which happens at pi. So those are my three answers. Eight I did in class, but if you want to see a reminder of it, it'll come up in just a second. Okay, there you go. It asks for all solutions, so I just have that. Well, I started with the plus 2 and pi, but when I divided by 3, the plus 2 and pi over 3. I do not need to list out all of the solutions between 0 and 2 pi, since I did not ask for that. On number 9, finding all solutions. So I'd subtract my 3 over. So I have 3 times tangent of x over 2 equals -3. Divide by 3, so I have tangent of x over 2 equals -1. Tangent equals 1 or -1 if you're thinking about that pi over 4 spots. But since this is a -1, I need to be looking in quadrant 2 and quadrant 4. So I end up with 3 pi over 4 and 7 pi over 4. But if you remember, tangent, your period is just pi. So I only have to list the ones that go from between 0 and pi, and it'll take care of itself. So x over 2 equals 3 pi over 4 plus n pi. Multiply everything by 2. So I get x equals 3 pi over 2 plus 2n pi. And that's my answer. Okay, last one. Again, I instantly notice I'm dealing with secants and tangents, so I have to rewrite. I'm going to look to rewrite this one that's squared because I can rewrite that using my Pythagorean identities. And secant squared is actually 1 plus tangent squared. So I have 1 plus tangent squared x minus 2 tangent x equals 4. I want to get everything on the same side, so I'm going to subtract that 4 over. And I'm going to go ahead and put them in my normal order. So it'd be minus 3 for that part. And then start with my tangent squared x minus 2 tangent x. Again, if you need to come over to the side to factor x squared minus 2x minus 3, so be it. When you factor that, you should get x minus 3 times x plus 1. So that is actually tangent x minus 3 times tangent x plus 1 equals 0. Set each of those equal to 0. So I have tangent x minus 3 equals 0. Tangent x plus 1 equals 0. Over here, add 3 to both sides, so I have tangent x equals 3. When I think about tangent, it went like this, so I know that it went above 3 and even hit 3, so I'm not worried about it being outside of my range, but it is not on my unit circle. So I can do my arctan, or inverse tangent, of 3. Which, if you do get that on your calculator, should be about 1.249. Do you remember, since it said find all solutions, I gotta throw my little plus n pi in there. And then over here, tangent of x equals -1. So I'm thinking, where does tangent equal -1? And I would actually take this one probably written 2 ways. When I do, I'm thinking about doing my inverse tangent like I did on this part. When I do inverse tangent, I normally am staying in quadrant 1 or quadrant 4, which means I'd be looking at negative pi over 4 there. So you could tell me x equals negative pi over 4 plus n pi. But I may not necessarily think about that, and I could be thinking the way we've been doing them, where I would be up here at 3 pi over 4. So if you tell me x equals 3 pi over 4 plus n pi, these are the same thing, because if I have a negative 1/4 and I add 1, I do end up at 3/4. Then I'd add another 1 and so forth. Since n could be negative, I could say 3/4 minus 1, which would give me a negative 1/4. So they actually are saying the same thing. Be sure to let me know if you guys have questions. This does end our section on solving equations with trig functions, though.